Ladies and gentlemen, thank you so much for coming. I really need to be honest with you. So I have absolutely no idea of what just has been said in the last 30 minutes. But somehow these two guys managed to pump so much energy into me, and now I'm almost overflowing with vitality. So thank you so much for setting the stage. And of course, thanks so much to the organizing team for having me, but most importantly, thanks to all of you guys for joining. I'm just feeling flattered to have the chance to open the first day of this conference. So, I'm Ingo. I have been in software testing for about 10 years. And especially in the last 5 years, a pattern emerged. A pattern emerged in the discussions I've had with so many people all around and about software testing. And in most of these discussions, I observed that AI became more and more and more essential topic. And most of these discussions, especially after a couple of beers, always ended up with this question: will a bot steal your spot in software testing? Now, that's the simple reason why I'm here today, because I want to tackle this question in that session. Now, for those of you who need or want to leave in about 1 minute, here is my short answer to this question, and it comes in 2 parts. First, I believe that in the near future, that means in the next 15 to 20 years, it's highly unlikely that machines will completely replace the human thought process from software testing. But in the distant future, that means everything that happens next, I think it's quite likely that machines will just take us over with respect to almost any human intellectual task. Now, most of my talk will focus on the near future of AI in software testing, but I also want to give you at least my reasoning why I'm making such a bold statement about the far future of AI. And here my reasoning is based on 3 simple assumptions. Assumption number 1, I believe that intelligence is an emergent phenomenon. So I believe that intelligence is just a byproduct of especially complex information processing. Now, in short, this just means that I don't see a necessity for a metaphysical entity like a soul or a god that allows us to be intelligent. That's assumption number 1. Assumption number 2 is I believe that we will continue to improve our technology. So we will continue to improve our technology with respect to its computational power, with respect to its memory capacity, also with respect to the data we will have available to train our AI systems. So my assumption just here is that technology will continue to advance. And most likely it will continue to advance in ways we can't even comprehend nowadays. That's assumption number 2. Assumption number 3 is that here I'm almost convinced that we are, as humans, by far not at the peak of intelligence. To me, the space of all possible intelligences out there is simply too vast. And human intelligence is just a type of intelligence biological evolution can produce. And to me, this type of intelligence is just a minuscule dot on a minuscule dot on a minuscule dot in the space of all possible intelligences. So guys, if you're also saying, well, these assumptions make sense to me, then I think you will have a hard time finding anything that will fundamentally block us in creating machines that are far surpassing the intelligence of the brightest human minds. But I want to make it crystal clear here. So everything I've just said is what I believe. Now, unfortunately, I can't give you any evidence for that, or I can't give you any solid reasons for that. And that is what Richard Dawkins calls faith. So he says faith is belief without evidence and reason. Now the problem here is that this is also the definition of delusion. So what does it mean for you guys? Well, it just means that everything you hear in the talk is an opinion. It's my opinion. It's not a fact. And everything you see in the talk is a perspective. It's my perspective. It's not the ultimate truth. So according to Richard Feynman, all I want you guys to do is to keep asking and to keep doubting, because then it gets a little harder to believe. And I think that is probably the best advice someone can give to you when someone else is talking about AI and software testing. Now, having that said, guys, let's now get into the nitty-gritty and let's explore the near future of AI in software testing. And I want to do that in 3 parts. In part A, I would like to briefly explore the hype that is around AI in general, to even figure out why we are even asking this question: will a bot steal your spot in software testing? In part B, I would like to then explore the concept of intelligence to enable you to understand my answer to this question. And in part C, I would like to explore testing itself to finally give you the answer to this question. So that's the master plan. I hope that works for you guys. Now let's dive right into it. And let me start with this person here. His name is Andrew Ng, and he's probably the most famous AI researcher out there. He's co-founder of the Google Brain Project. He is a professor at the Stanford University, and he once said, just as electricity transformed almost everything 100 years ago, today I actually have a hard time thinking of an industry that I don't think AI will transform in the next several years. And you know what? I fully agree with this guy. Because especially the recent achievements of artificial intelligence, they are just stunning, they are remarkable, and all too often they are just overwhelmingly impressive. And so in this preparation of this talk, I started to collect those awesome achievements from the recent past. And I ended up with about 43 examples I wanted to show to you. So I quickly realized that I won't be able to show you all these great achievements. And then just about 1.5 months ago, I came around something OpenAI released at the beginning of October this year. And what they did is they created a reinforcement learning algorithm based on a concept which is now called self-play, where they managed to train AI agents to play a game. And the game was hide and seek. And honestly, this just blew my mind. So here is just a 2-minute video that briefly explains what OpenAI did here. So watch it out.
These agents are playing hide and seek. These agents have just begun learning, but they've already learned to chase and run away. This is a hard world for a hider who has only learned to flee. However, after training in millions of rounds of hide and seek, the hiders find a solution. The hiders learn to use rudimentary tools to their advantage. By grabbing and locking these blocks, they can create their own shelter. The seekers are locked in place for a brief period at the start of the game, giving hiders a chance to prepare. Even so, the hiders must learn to collaborate, accomplishing tasks that would be impossible for any single individual. The hiders are not the only ones who can learn to use tools. After many generations of failing to break into the shelter, the seekers learn to jump over obstacles using ramps. However, after many millions of rounds of having their shelter breached, the hiders learn to take away the primary tool the seekers have at their disposal. Note that we did not explicitly incentivize any of these behaviors. As each team learns a new skill, it implicitly changes the challenges the other team faces, creating a new pressure to adapt. We've also put these agents into a more open-ended environment, randomizing the objects, team sizes, and walls. In this world, they learn to construct their own shelter from scratch, requiring that they arrange multiple objects into precise structures. To prevent seekers from using the ramps, the hiders move them to the edge of the play area and lock them in place. We originally believed this would be the final strategy that the agents learn. However, we found that after more training, the seekers discovered that they can jump on top of boxes and surf them to the hider's shelter. In the last stage of emergent strategy that we observe, the hiders learn to lock as many boxes as they can before constructing their fort in order to defend against box surfing. So how do agents acquire these skills? They're trained using reinforcement learning, an algorithm inspired by the way animals on Earth learn. The agents play thousands of rounds of hide-and-seek in parallel for many days. They train against each other, as well as past versions of themselves, using an algorithm called self-play.
You know, guys, when I first saw this and then digged a little bit deeper into especially the technical specifics of that implementation, my first thought was really like this. I just thought, well, given that pace of technology, I just propose we leave testing to the machines and we go play outside, right? I simply gave up. I was blown away, honestly. And I looked like this. And I just hyped myself up into thinking that AI can now achieve anything and everything beyond that, right? And I think all of us had such an experience at least once in their lifetime, right? You might have looked like this or like that or like this or especially like that once you realize the potential impact these AI systems could have on your professional life, right? But when you dig a little bit deeper into the technical specifics of these AI systems, you will probably look like this. Because you will start realizing that these intelligent computer systems aren't made of magic, they are made of pure logic. And that's the good news here. But nevertheless, it's just a fact that nothing, really nothing, has moved as fast as AI is moving right now in the enterprise. And the press is full of statements such as AI is the new paradigm, the next digital frontier, the next disruptive force in technology, at least for the next decade. Or AI is the new black or the new electricity. And believe it or not, but some people even go beyond that. People like Raymond Kurzweil. Now, Ray Kurzweil is a futurist. He is an author, and he is currently employed at Google as a director of engineering. And in 2005, he wrote an awesome book. Highly recommend to read it. It's called The Singularity is Near. And the ideas he's sharing in this book were already developed back in the late 80s and early 90s. And the ideas he is sharing in these books and in all the papers that followed from the books make really, really bold statements about the far future of AI. So in these books, he claims, for example, we will be able to fully back up our brains. We will be able to think in the cloud. Or we are going to put gateways to the cloud in our brains. Or by the late 2030s, human thought will be predominantly non-biological. Or now it comes, we will be uploading our minds to computers and become emotional by 2045. So 2045, guys, is definitely a year you have to mark in your calendar. Because at least, according to Raymond Kurzweil, this is where we will reach the so-called AI apocalypse. It's also known as the AI takeover. And that's usually the point in time where we have machines that are just millions of times more intelligent than human beings. So what is the reasoning behind Raymond Kurzweil? Well, in really short terms, his reasoning is based on what he calls the law of accelerated returns. And that, again, in really rough terms, is based on Moore's law. Now, we all know that Moore's law just states that the number of transistors in a dense integrated circuit doubled every 2 years. Now, what Kurzweil says is that this doesn't just hold true for transistors. He claims that this holds true for technology in general. So he is saying that technology becomes more powerful at an accelerated rate. And this, in short, just means technological advance, according to him, is not linear, it's exponential. And then another guy from the University of Wellington, Nick Ager, came around and asked himself, well, what does it take to get there? What does it take to reach the apocalypse? And he broke it up into two parts. He said, part A, we just need to master the software of human thought. We need to be able to describe the human thought process algorithmically. Now, once we did that, we just need to have machines that have at least the computational power and the memory capacity of human brains. And then we are there. Now, quite surprisingly, it appears to me that most people in the software testing business think that this is just around the corner. Because I hear so many people talking about automated testing. And sometimes it appears to me that they truly believe that we are just a baby step away from eliminating the need for human thinking in software testing. Because it's so easy, right? Now, I don't believe that, and I don't want to sell you AI like this. So I don't want to sell you AI in software testing in the same way miracle weight loss programs or anti-aging face creams are being sold to you. So I really want to discuss this topic in a serious way. Now, to do that, let us first explore the concept of intelligence. And Robert Sternberg once wisely said that there seem to be almost as many definitions of intelligence as the number of experts asked to define it. And this just means that there is no standard definition of intelligence out there yet. So in the preparation of this talk, I tried to find a definition of intelligence. And in my search, I came around this paper. It's called A Collection of Definitions of Intelligence. And in that paper, two very well-known researchers in the field of AI, Shane Leck and Markus Hutter, they collected 70 definitions of intelligence from various fields, from mathematics, physics, psychology, philosophy, from AI research or computer science in general. And they also collected definitions of intelligence from various organizations, such as Google, Netflix, Amazon, and so on and so forth. And what these guys were trying to do was quite interesting. They tried to extract the core attributes of intelligence from all of these definitions, and then they tried to compile what they call a universal definition of intelligence from these core attributes. Now, when you follow their thoughts in that paper, you will see that intelligence is often related to phenomena such as emotional thinking, critical thinking, logical thinking, problem solving, communication, perception, modeling, planning, abstraction, generalization, learning, imagination, creativity, memory, experience, understanding, judgment, analysis, the ability to manipulate environments, the ability to adapt to ever-changing environments, or the ability to set strategic goals. And you know, when I first realized this, I just thought, well, intelligence is really just a suitcase term. It's just an enormous suitcase to me that contains all sorts of these phenomena we can't really explain. So it's like taking all these phenomena like critical thinking, generalization, abstraction, we put it into a suitcase, we close the suitcase, and then we call it intelligence. So that is how I like to see this term. Now, one definition I really liked most in this paper was this one here by Edwin Boring. And he said, intelligence is what is measured by intelligence tests. That keeps like obvious, right? And I thought, well, that's interesting. So what are these tests? And just after a 30-minute research, I came up with those tests here. And I think we all know the Turing test. But there's also a reverse version of the Turing test out there, and that is where you have a general purpose AI, and that general purpose AI, through some magic, creates the necessity to perform a Turing test on you. Now, this is now seen as the true Turing test out there. But the one I really liked most is the one here at the bottom, the so-called Ikea challenge. And here you have a robot, you embed a general purpose AI into that robot, and then you just ask that robot to put something together from Ikea, some furniture, a chair or a table, for example. And quite surprisingly, I wasn't able to find any case study that really shows that a general purpose AI is able to achieve that. Now, some people say that says more about Ikea than it says about the field of AI research. Anyway, the definition these two researchers in that paper came around was this one. They concluded that intelligence measures an agent's ability to achieve goals in a wide range of environments. And I know, right, still fuzzy, still abstract, but to me it's quite an okay definition, because it at least allows us to proceed working with it. And then a little bit later, another well-known AI researcher, Chris Bishop, came along and said, guys, I mean, when this is intelligence, then artificial intelligence is definitely anything machines can't yet do. And I guess the reason why he came up with that statement was that these guys in that paper were talking about the most general form of intelligence. And so they were referring to its most general form of artificial intelligence. And that form of artificial intelligence is now called as AGI. Sometimes it's also misleadingly referred to as pure, strong, full, or general purpose AI. And in really rough terms, here you have a machine or a computer system in general that has the ability to apply intelligence to any problem. Now, this doesn't mean that these computer systems can solve all problems. It just means that they are, in principle, able to apply intelligence in the way we defined it before to any problem out there. And this, of course, begs the question, well, will we humans ever be able to create that very general form of artificial intelligence? Well, Martin Gruff, the researcher from Down Under, has a take on this, and he says, no, this is never going to happen. Why? Because humans simply aren't generally intelligent. Now, that's obviously a fun statement, right? But the point here is that AGI, artificial general intelligence, is a form of intelligence we don't have yet. So to me, AGI is just the study of what we could do with machines we don't have. And it's still an open question if we will ever have that. Now, what we have at the moment is a very narrow form of AI, and that is now called ANI, Artificial Narrow Intelligence, sometimes also referred to as specialized, weak, or purpose-specific AI. And here you have a computer system that has the ability to apply intelligence to a very specific problem, or to problems in a very specific domain. And this is the type of artificial intelligence that surrounds your daily business. Now, we've all seen these great achievements or these ANI systems that just outperform humans, for example, in recognizing faces. The Facebook Recognize is just one of many examples. We've seen those amazing cognitive services Microsoft provides through their Azure platform, right? In that example, you just upload a picture and you get an interpretation of this picture. Now we have seen ANIs that just outperform humans in playing games, such as Jeopardy. IBM Watson Jeopardy is the keyword here. Or we have seen ANI systems that just outperform humans in detecting diseases. Now, IBM Watson Healthcare is the keyword here. Or we have seen ANI systems that just outperform humans in playing games, board games like shogi, chess, or Go. And here, of course, AlphaGo and AlphaZero from DeepMind, now acquired by Google, these are the keywords here. And just last week, I came around a story that really made me think. And this story is about this guy here. His name is called, he's called Lee Sedol. And Lee Sedol was the guy who was beaten by AlphaGo in 2016 already. So he was just blown away by this algorithm. And he's 36 years of age. He's already won the world championships in Go 18 times already. So he is known to be the best human Go player on that planet. And just last week, he retired. And retired for a reason. He said, an AI is now an entity that cannot be defeated anymore. So basically, he gave up. And this means he lost all his inspiration and motivation to play Go anymore. And to me, this is just a sign of things to come when machines become more and more powerful at very particular tasks. Now, another thing that shouldn't be missed to talk about in the talk about AI are self-driving cars, right? Google, Tesla, these are the keywords here. And self-driving cars are a great leap forward, and probably they will become a commodity, especially in China or in California in the next 5 years. But the thing here is, they can only do one thing. They can drive a car. Or have you ever seen a self-driving car, for example, making a sales prediction, a weather prediction, or interpreting an image, or playing chess or Go? No, you haven't. Now this, of course, then begs the question if we are able to create an artificial general intelligence from an artificial narrow intelligence. And one advocate of this idea is this person here. His name is Ben Goertzel. And he is, as far as I can see, the leading scientist in the field of artificial general intelligence. So he's co-founder of Singularity Net and OpenCog. We'll get to that in a second. So if you don't know Ben, you probably know her, Sophia from Hanson Robotics, right? And Ben was the head of the engineering team that built Sophia at Hanson Robotics. And Sophia, by the way, was the first robot that was given a citizenship for a country, Saudi Arabia in that case. So Ben Goertzel is an advocate of the idea that you can create an artificial general intelligence from a network of artificial narrow intelligence systems. And all these ideas were already shaped and talked about back in the 80s, especially by this guy here, Marvin Minsky. He unfortunately passed away, I think, 2 years ago. And he described that approach in a fabulous book. It's called The Society of Minds. So in this book, he lays out the framework and the conceptual idea of how to achieve that task. And Ben Goertzel tries to put that idea into practice by a platform which he calls Singularity Net. Now, Singularity Net, according to Ben Goertzel, is a so-called decentralized AI network. It's a blockchain-based AI platform based on the Ethereum platform. And the cool thing about it is it's open to everyone. So everyone can contribute to that. Everyone can create, share, and monetize those AI services on that platform. And the first beta version of that platform was released just this year. And I think they are now at version 3. Now here is a sneak description of how that platform works from my naive perspective. So now imagine that this rectangle here represents Singularity Net. It represents this decentralized AI network. And now imagine you put a request into that platform, like you want to have some problem solved. You want to have a sales prediction, a weather prediction, or any other problem. Then you put that request into that platform, and that platform then consumes that request. And in that platform, you will find a bunch of different ANI systems. So that means computer systems focused on solving a very specific problem. Like one is for image interpretation, another one is for natural language processing, another one is for translation, another one is for playing Go, for example. Now, this request is then consumed by the platform itself and not by an individual system. And these systems are able to talk to each other, to collaborate with each other. That is what they do via smart contracts, for example. Now, and they can also rate against themselves each other, and they can offload work from each other. And once they are done with the task, they just give you the response back. So this is just a rough description of what Singularity Net does. Now, the vision behind it, that's the interesting thing. The vision behind Singularity Net is out of that interaction between all these individual ANI systems, the hope is that a general form of intelligence just emerges. That's one of these reasons why Ben Goertzel created that platform. And this sounds like a crazy idea, right? It's more like a hope. But an interesting thing is that this is also being researched on at various universities already. For example, at the Free University in Brussels, there is an institute, the so-called Global Brain Institute, that is just devoted to the task of finding out whether this can be true or not. And Singularity Net was one of these first decentralized AI networks out there. And quickly after its first release, a bunch of other decentralized AI networks popped out of nature. And what do you do in that case? You create an alliance, and that is what they did, the so-called DAIA. It's like a decentralized AI alliance of decentralized AIs. So you can think of it like an ecosystem of ecosystem, or a network of network. And it's like our body, right? Our body is nothing more than just a network of network. Or our society is nothing more like a network of network. And again, the hope of putting all those alliances together is to create some general form of AI at the end of the day. And that is the cutting edge of AGI research as far as I can see. So now let's see what all this means for software testing. First, I want to make sure that we are all on the same page. So let me briefly share with you how I see our discipline. And for this, I need your imagination. Now imagine that this rectangle represents your software product. It represents all the entire functional and non-functional spectrum of your software. And it also represents all the environments your software could be situated in. And also represents all the different users that might use your software. So try to imagine that. So that's all there is, and that's all you could possibly know about your software. Now then, the green rectangle represents all what you currently know about your software. And this rectangle is apparently smaller than the previous one, because I'm convinced that you will never be able to always know everything at any time about your software. The red rectangle then represents all what we repeatedly check in our software through, for example, automated test case execution. And again, this rectangle is smaller than the previous one because I'm convinced that you will never be able to always check everything at any time in your software. Now the question here is, well, would it make sense to go for that? Would it make sense to strive to automate, to codify all your knowledge? Well, some people would say, yes, of course, that's the goal, right? We have to automate the testing. But I'm saying no. Because if you solely aim to codify all your knowledge at any point in time, the question is, how on earth would you then create new knowledge about your software? And you have to create new knowledge about your software. Why? Because your software constantly grows. We're adding more and more features to our software. We are changing our software on a daily basis. And so you constantly need to expand the knowledge about your software on a daily basis. And why? Well, to be able to detect problems in your software that are far, far outside your checking regime. And that is exactly how I like to see testing. Now, testing to me is all about closing this knowledge gap. It's all about closing the gap between what we know and what we don't know about our software product. So testing to me is all about collecting information rather than doing automation. And this means that testing always has been and probably always will be a search for information. And the type of information we search for is quality-related information, right? For example, the risks, the problems that might happen in your software. And the reason why we collected quality-related information about our software is to enable other people, like product owners, product managers, to make better decisions based on the information we provide. Decisions such as fixing decisions or shipping decisions. So that's my short view on software testing. So from that perspective, I like to see something as thoroughly tested when it has been checked by efficient formal test case automation and when our software has been explored by the richness of intellect of human beings, by you guys. So to me, from that black and white perspective, software testing, or the coin of software testing, has two sides. The first side is all about checking, where we monitor our known risks. Here we confirm what we already know. And the second side of the coin is all about exploration, investigation, and experimentation, for example. And here it's all about analyzing potential risks, collecting new information about our software. So that's level number one. Let's dive one level deeper. Let's briefly make sure that we speak the same language when it comes to those two terms. Now, when we check something, then according to Michael Bolton, we evaluate our software by applying algorithmic decision rules to specific observations of a product. Now, usually no one gets what that means, right? So in short, this just means that here we operate our software in a mechanistic way. And the reason why we do that is to provide an answer to a very simple question. And that question is, does this assertion pass or fail? Now the thing here is that the answer to this question is always a binary answer. It's either yes or no. And this means that this question is machine decidable. And this means that this question, or the process of answering the question, can be automated. And you know what? It should be automated, because I don't want to do what a machine does, right? I want to evaluate my product by learning about it through exploration and experimentation. And the reason why I want to do that is to tackle a much, much bigger question. And that question is there a problem here? And this question usually does not have a binary answer. So from that perspective, one can say that everything that happens on the left side of that testing coin is something that can be described fairly easily algorithmically. So it's something that can be automated in a fairly easy way. Everything that happens on the right-hand side, that is something that is really, really hard to automate. Let's go one level deeper. And let's ask ourselves, well, what the heck do we even need to do before we are performing a check and after we perform the check? And think of the check of you create an automated test case and you execute it, okay? So before you are able to create that automated test case and execute it, you have to learn about your software. And this means you study your software. And this means you study the specifications, the design documents, the architecture documents, and you talk to a hell of a lot different people, to your product owners, to your product managers, to your developers, to your testers' friends, and so on and so forth. So all this helps you to create some knowledge about your software. And this then helps you to lull yourself into the illusion that you understand your software. Now, based on that understanding, you are then able to recognize, identify, and most importantly, you are able to prioritize risks in your software, problems that might happen in your software. And then you take those risks and you translate these risks into test ideas. And then you express these test ideas into binary yes or no questions. And the reason why you want to do that is you want to turn these questions into code, because you want to create an answer to these questions in an automated way. So then you just need to find a trigger to launch these checks, then you encode the trigger to automate, and then you perform the check, okay? So these are all the activities you need to do in order to even be able to automate a test case and to execute it. Now, what happens after that? Well, after that, you must read the bits, you must read the results, you aggregate those results, you design reports, right? You encode those reports because you realize, well, I don't want to design those reports again and again and again, right? And then you need to observe those reports. And the reason why you need to observe those reports is you need to determine the meaning and judge the significance of all the results in your reports. And based on what you find there, you are able to respond and to learn something new about your application. And the whole game starts again, okay? So from that perspective, one can easily conclude that checking, and especially automated checking, some call it test automation, some call it test case automation, is just a tiny little dot in the vast space of testing. Now let's go one level deeper, and let's ask ourselves the question, well, what are all the testing activities we perform when we are doing testing? Now I did that exercise. Here is my substitution of testing. So when I'm testing, that means when I'm challenging my software to evaluate my software, I'm applying a bunch of activities, such as learning, exploration, experimentation, modeling, drawing inferences, questioning checks. I'm applying judgment, critical thinking, emotional thinking, logical thinking. I'm developing a hell of a lot of test code. I'm studying customer feedback. I'm dealing a lot with emotions. I'm building relationships. I'm scrutinizing illusions. I'm not only verifying, also validating my software on a daily basis, right? And so on and so forth. So this list could go on and on and on forever. And that's my personal list, by the way. It might be not your list, right? So when you want to have an answer to the question, can testing be automated? My advice to you is just go out there and think of all the activities you do when you do software testing. And then for each and every item on that list, just decide whether this can be automated in its entirety or not. And here you go, you get your answer. It's as simple as that. Now, when you do that, you will find it's a very hard decision you have to make because you don't know all the tools out there that might, or at least promise, to help you to automate those activities. So here is just a short list of tools that position themselves exclusively as so-called AI-based testing tools. And they make really, really bold statements. They say, we automate every step of the testing lifecycle. We automate test design, test planning, and test execution. We provide autonomous exploratory testing, for example, to you, right? Now, I don't want to talk too negatively about these tool vendors because I highly appreciate what they are doing. They make the first step into bringing AI and ML into our business. So the guys I'm really blaming here are their marketing teams, honestly. So when you do that exercise, and please do that exercise, maybe after the conference, create that list of activities you perform when you do testing. Evaluate those tools. There's a trial available for all of these tools, freely for at least a month. And then decide for each item on that list whether your testing can be automated or not. Now, I also did that exercise. And my conclusion, it's kind of obvious, right? There is no such thing as automated testing out there yet. Just as there is no automated programming yet, right? Or just as there is no automated product management yet. So to me, I still like to talk about automation in testing, not about automated testing. Now, when we talk about testing, we also talk about quality, because it's simply so hard to not talk about quality when you talk about testing or the other way around. So what does it even mean? Well, when you look it up in the dictionary will tell you that quality measures the degree of excellence of something. And I think that's quite of an okay statement, but that's not the point. The question here is who measures this degree of excellence. And it's always measured by someone out there. And therefore, Jerry Weinberg once wisely concluded that quality is value to some person who matters at some time. Now, the person he is referring to here are the stakeholders, the people for whom we are building our software products. And they might come and they might go because your market constantly changes. So far, we just replaced the term quality with the term value, right? It doesn't really provide any value here. So what do we mean by providing value? Well, by providing value to someone, it means that we help these people to solve their problems, to satisfy their needs, to satisfy their desires, their wants, for example, right? And so I am a product manager, by the way, and here is my rule of thumb, how I like to see our product. I like to see our software products just as a solution to someone's problem. And I always remind myself about this in every sprint planning meeting, backlog refinement, or daily stand-up meeting. Whenever we talk about our software, I always remind myself that we are only building a solution for someone else out there. And that someone else is always a human being, in our case. And so if the problem isn't solved with our software, then the software simply doesn't work. So this means that quality is subjective. It's inherently subjective. And this means that different stakeholders will perceive the same products as having different levels of quality, right? So what might be usable for you in some piece of software might not be usable for me. And this means that we as testers, we must look for different things for different stakeholders. And this says a lot about what a bug is. Now, to me, a bug is, in its most general form, is anything that somehow threatens the value of our software product. And James Bach once said, a bug is something that bugs somebody. Now, that's again a fun statement, right? But there's a deep meaning related to that. So he's saying that a bug is not necessarily within the software product. It's more about the relationship some people have with your software. And exploring that relationship, that is to me a testing activity. That is the type of testing I do on a daily basis. Again, to me testing just means challenging software to evaluate software. And when I'm saying evaluating software, I'm just meaning that we make value judgments about the software. And in really short terms, this just means assessing whether our software is good or bad for a specific person in a specific context. So this means when I'm doing testing, I'm studying humans. And because of the fact that social science is the study of humans, one can easily conclude that testing is a social science too. Now, so it means when we talk about automated testing, we necessarily also talk about automating social science. And this means that we have to do that. We need to automate social science. And this turns out to be a really hard thing to do. And this might be caused by what I like to call by the peculiar dignity of tacit knowledge. Because studying humans means managing a lot of tacit knowledge. So what do we even mean by tacit knowledge? Well, this was once perfectly described by Harry Collins in his book Tacit and Explicit Knowledge. Now, tacit knowledge is often referred to as implicit knowledge, especially in neuroscience. Now, tacit knowledge is just a specific type of knowledge that is hard to transfer from one person to another by verbalizing it or by writing it down. Okay? That's it. So it's knowledge based on our hunches, based on our intuitions, feelings, perception, and the experiences we have. And the interesting thing here is that most of the knowledge in an organization is in people's heads. Most of the knowledge is tacit knowledge. That's why there is this saying out there, you know more than you can tell. So tacit knowledge is knowledge that is hard to share because you cannot really formally express it, okay? But on a daily basis, we do it, we transform tacit knowledge into explicit knowledge. So that means we make it explicit in forms of writing something down, talking to each other, in terms of facts, files, records, or data, for example. So that means when we want to automate testing, okay, we need to automate at least aspects of social science. And this means we also need to automate the management of tacit knowledge. Now, a very classical example of tacit knowledge is facial recognition. And that is one type of tacit knowledge that can be automated already. So for those of you who know me, you know that this is my face, okay? This face belongs to Ingo. And you can probably identify my face among even millions of different people. It's an easy task for you, right? But when I'm asking you to write down concrete rules in an algorithmic way that uniquely identify my face, you will have a really hard time to do that, okay? So this means we cannot really formally express it. But this is a type of tacit knowledge that can be already handled by machines, by, for example, convolutional neural networks. But there are other and many forms of tacit knowledge which cannot be handled by machines yet. Just as the assessment and interpretation of our stakeholders' needs, their wants and their desires, for example. So again, the bottom line is automating software testing means automating social science, and this means automating tacit knowledge. And this means when we want to automate software testing, we need to understand the human behavior and especially the interactions between humans and their software in an automated way. Now, this is complicated, right? But that's not really the question. The question is it too complicated to be done? Well, some people say, yes, of course, right? And then they throw statements like this to you. They will tell you, if the human brain were so simple that we could understand it, we would be so simple that we couldn't. Which simply means, if humans were so simple that we could describe them algorithmically, well, we would be too simple to build these algorithms. Well, we already know that this statement is just wrong in a special case, because we already build machines that are smarter than us in very certain dimensions, playing Go, for example, or playing chess. But to me, this statement is one of the key statements in its general case. And so far, the true value of that statement to me is neither true or false, it's still undecided. Now, having all that said, guys, let's briefly sum it up. Let me share at least the 4 main lessons we have learned so far. Number 1, Jerry Weinberg, I think he nailed it. He once said the number 1 testing tool is not the computer. It is still the human brain. And I think this statement still holds true nowadays. So the most important intelligence isn't artificial yet, guys. Never forget that, please. And so please do not hype yourself up into thinking that AI can achieve everything and everything beyond that. So my advice to you is do not hype yourself up into thinking that AI can solve all your testing problems soon. Rather do something about natural stupidity in testing now. And there's a lot of things we can do here. So please, please do not think like that person in that picture, okay? Until, of course, some general purpose AI like Skynet comes around and takes over the world of software testing. But as far as I can see, this won't happen anytime soon. So I kindly ask you to think about AI-assisted testing and not to talk or think about AI-based testing. Why? Because testing to me is a thinking activity, and we all should treat it like that, okay? It is something that happens in our heads. It's not something that happens in our tools. And so my main message here is that automating our discipline, automating software testing also includes the automation of the human thought process. And if that will once happen, okay? If a bot will once steal your spot in software testing, don't be worried, because I'm convinced that this bot will steal everyone's spot everywhere too. Thank you so much.